Good afternoon, dear students. Today we'll discuss about some of the aspects related to environmental pollution. So, in this environmental pollution, basically we will going to discuss about the sources, effects, and control measures of carbon dioxide, carbon monoxide, sulfur dioxide, as well as particulate matter. Now, first we will discuss about carbon monoxide. So the sources of carbon monoxide is the first source of carbon monoxide is methane. So the methane is the first hydrocarbon, the first homologue of an hydrocarbon. So the methane is formed immediately when the animal or vegetable matter decays. So the vegetable matter and animal matter, when it decays, it releases methane. So this oxidation of methane, aerial oxidation of methane, releases carbon monoxide into the atmosphere. So that is the first source of the carbon monoxide uh, uh, into the atmosphere. Now the second source is the automobile exhaust. So carbon monoxide is released into the atmosphere by the incomplete combustion of a fuel. So the fuel in the form of petrol and diesel will be used in the automobiles, and incomplete combustion of such fuels will release carbon monoxide into the atmosphere. So that is also one of the source of carbon monoxide. Then the next is the incomplete combustion of fossil fuels. So any form of fossil fuels, or like coal or the gasoline, or maybe petrol or diesel, when it undergoes an incomplete oxidation, and instead of forming carbon dioxide, complete oxidized product, it will form an intermediate carbon monoxide that pollutes the atmosphere. Now, when you look into the reactions, so the carbon containing compounds, in the fossil fuels, or maybe in the petrol or diesel fraction. So when it reacts with the oxygen, so the incomplete combustion takes place. So due to the incomplete combustion, it will form a pollutant, that is what is called as carbon monoxide into the atmosphere. Now, industries, there are certain industries like steel and petroleum industries, which will release carbon monoxide into the atmosphere. So, in these industries, so the carbon dioxide, when it liberates, it will react with the carbon. So, the carbon dioxide is the complete oxidizer product of an carbon, which will react with the again carbon and releases carbon monoxide. So such industries releases especially the carbon dioxide. Carbon dioxide further reacts with the incomplete carbon and releases the carbon monoxide. And 2 moles of carbon dioxide can also thermally decompose, and at the high temperature, because steel and petroleum industries operates with very high temperatures. So in at that temperature, in the chimneys, the carbon dioxide will undergo thermal decompositions, and it will releases the carbon monoxide into the atmosphere. So these are the sources of carbon monoxide. Ill effects. Now, the major ill effect of carbon monoxide is that for the living beings, so the hemoglobin in the blood will react with an oxygen continuously and form an oxyhemoglobin. So, if the air contains carbon monoxide, so the first form of a pollutant, so it readily combines with hemoglobin instead of forming oxyhemoglobin, and it will start forming another compound, what is that is called as a carboxyhemoglobin. So once the carboxyhemoglobin forms, oxygen carrying capacity of blood decreases. So this is the major ill effect of all living beings. So and this causes headache, dizziness. It may lead to an unconsciousness, and when inhaled for a prolonged long period of time, it even causes the death. So the major ill effect of carbon monoxide is the first, instead of forming oxyhemoglobin in a regular percentage of oxygen, if it present in the atmosphere carbon monoxide in excess, it readily combines with hemoglobin and forms in carboxyhemoglobin, and that carboxyhemoglobin capacity, oxygen carrying capacity of the blood decreases, hence it causes several illness. Now the control is using a catalytic converter in automobiles. So catalytic bed will be attached to the automobile engines, so which will reduce the incomplete combustion of the flue gases. Flue gases is the gases which is mixed with when you burn a fuel, the all the gases will liberate along with the carbon monoxide, carbon dioxide, sulfur oxides, nitrogen oxides, etc. So the next pollutant is sulfur dioxide. Now, the sulfur dioxide, major source of the sulfur dioxide is the fossil fuels. Now, the fossil fuels not only made up of hydrocarbons, it also consists of little amount of sulfur. And when you burn this fossil fuel, like coal or a crude oil, especially, and when you burn this fossil fuel, sulfur present in the fossil fuels will oxidize and convert into an sulfur dioxide. So that is the first source of an sulfur dioxide. And the second source of sulfur dioxide is roasting of ores. So the majorly the ore is roasted before taken for the, there are several steps for the processing of the ores. One of the step is the roasting, and in this roasting process, sulfide ores, especially when the sulfide ore is roasted, sulfur which is present in the ore, which will convert into an sulfur dioxide and sulfur trioxide, and which will be released into the atmosphere, and which will combine with the moisture and subsequently forms an acid rain. And the second source of sulfur is the roasting of ores. And so the reactions, how these reactions takes place. So suppose to extract the lead, so lead sulfide is the source of an ore. Okay, so when it is roasted in presence of an excess of an oxygen, so the lead combines with easily with the oxygen and forms a lead oxide, and sulfur will get oxidized into sulfur dioxide. So in this equation, so you can very clearly understand how the sulfide ore reacts with the oxygen and giving rise to sulfur dioxide as a pollutant. So the secondary source of pollutant. Now this sulfur dioxide, formed sulfur dioxide, immediately reacts with the oxygen again and forms sulfur trioxide. So the two pollutants, one is sulfur dioxide, that is the primary pollutant, and from the primary pollutant it will form a secondary pollutant, that is what is called as sulfur trioxide. Both these will react with the water. Sulfur trioxide reacts with the water and it will form a sulfuric acid. This sulfuric acid is nothing but an acid rain, and it will fall in the form of an acid rain. Now oxidation of H2S, hydrogen sulfide. So hydrogen sulfide also, hydrogen sulfide is one of the product which will be obtained when you when the plant undergoes decay. So this hydrogen sulfide gas reacts with the oxygen gas in the atmosphere, and which also releases sulfur dioxide. So that is also one of the source of sulfur dioxide. And this you can see the hydrogen sulfide which will be released in the decay of animal or vegetable matter. So the especially major decay of vegetable matter releases the hydrogen sulfide, which reacts with the atmospheric oxygen, 3 moles of atmospheric oxygen, and releases 2 moles of sulfur dioxide and formation of 2 moles of water. So this is also another source of sulfur dioxide. Now the ill effects. So ill effects is the first form of an ill effect is that sulfur trioxide and dioxides both are for humans. It's an eye irritant, and when it and it causes cough lung diseases, including lung cancer and prolonged breathing. It may cause an asthma. So in humans, it causes the first is the eye irritation. So these are eye irritants. Sulfur dioxide, especially, is a strong eye irritant. So in plants, it causes damages to leaves. Bleaching of chlorophyll takes place, and which may turn the leaves color into a brown and damages the crops production. And others is yellowing of paper and wearing of leather. Both are the ill effects of sulfur dioxide. Now, how to control the sulfur dioxide emission? So the first is, so when the during the combustion of fossil fuels, as I said, in 3% of approximately will contain some sulfur, and the fossil fuel gases are passed through a calcium carbonate. Now a bed is made, calcium carbonate bed is being made, and the gases are passed through a calcium carbonate bed. So if the gas contains an sulfur dioxide as an impurity or an impure gas, so that sulfur dioxide reacts with calcium carbonate. You can easily see from the equation, sulfur dioxide SO2 reacts with CaCO3, calcium carbonate, and it forms an calcium sulfite and releases carbon dioxide. Now, lime is added to the coal before burning, so and roasted at high temperatures. So, appropriate amount of lime is added. Lime is calcium oxide, and which is added to the coal, appropriate amount around 3 to 5 percentage, and is roasted at high temperature so that calcium oxide calcium oxide which will be combined with SO2 if and to form an calcium sulfate. So calcium oxide will react with sulfur dioxide in presence of a less amount of an oxygen during the roasting process, and it forms a calcium sulfate. So by converting sulfur dioxide into an calcium sulfite and calcium sulfate, will control the production of or emission of sulfur dioxide into the atmosphere. Now, particulate matter. So the third type of an impurity, third type of pollutant is the particulate matter. Now, particulate matter is the small matter which will be suspended in the atmosphere in the form of a solid, or in the form of a liquid, or maybe solid in liquid, or liquid in solid, as in this in the form of a suspension in the air. And they are also called as aerosols, and these comprise of dust particles, these aerosols, and ash, smoke, fumes, mist, etc. So now the sources of these aerosols, the first is the largest source is the volcanic eruptions. So the volcanic eruptions will continuously release ash, smoke, fumes, and even the dust particle into the atmosphere, and which will form an particulate matter in the atmosphere. Now the second one is soil erosion. So soil during the soil erosions, the dust goes into the atmosphere, and which will combine with the moisture, and it forms a particulate matter. Now, the third source is industrial operations. So, industrial operations such as crushing of the solid materials and grounding of the solid materials, or any solid materials, and and powdering the solid materials. So, during these industrial operations of crushing, grinding, grounding, it releases small particles into the atmosphere. And the fourth one is burning of the coal. So the coal when the coal is burnt, there is left out material which is non-combustible in nature. So these non-combustible matter after the burning of the coal, so that is, you call it as in the form of an ash, and this ash is also causes the goes into the atmosphere and act as a pollutant. Now, incomplete combustion of compounds containing carbon. So, any form of carbon which will be used as a burning, even maybe the wood or the processing of the coal or cement, asbestos, etc. So, these matter when it is being burned. So, if it is burned incompletely, the left out material, that is the non-combustible materials, and the ash will cause as a pollutant and in the form of a particulate matter. Mist. So the condensation of vapors, sprays lead to the dispersion of liquid. So these liquid dispersions, the mist is also another form of a pollutant. Now, the how to control this particulate matter. So the first is before going into the controlling measures, first we see the ill effects. Now the ill effects is first is when the particulate matter is dispersed into the atmosphere. First, it decreases the visibility. So the visibility and the transmission of light and transmission of sun rays. And when particulate matter enters into lungs, especially causing wheezing, bronchitis, and even in the prolonged inhalation of this particulate matter causes the asthma. So in plants, these particulate matters settle on the leaves, and especially you know that the plant operates or breathes through the stomata. So it blocks the stomata, so affecting the plant growth. So the stomata will be covered with these particulate matter, and hence it will affect the growth of the plant. So, how to control these particulate matter? Now, the controlling measures of these particulate matter. First one is gravitational settling chambers. So, these second one is centrifugal separators. The third one is fabric filters. Here, in the fabric filters, cotton, or in the form of a glass wool, or in the form of a small silk threads used as filters. And wet scrubbers, these are very important. Industries will operate with wet scrubbers. And fifth is electrostatic or an quaternion electrostatic separators. Now in the we'll go in detail with the one by gravitational settling chambers. So in these gravitational settling chambers, there is a flue gas is allowed into a rectangular settling tank. So there is a flue gases. Flue gas is nothing but the gases which is a mixture of all the gases, so like in carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen oxide, etc. And slowly these suspended matter which is present in the flue gases will get deposited on the surface of the gravitational chamber, and later these particles are removed. Such chambers are called as gravitational settling chambers. Now, the second one is centrifugal separators. Now, centrifugal, the name itself will indicate it consists of centrifugating apparatus. So the gases, the flue gases, is allowed to circulate in the spiral manner, and so during this circulation of the gas in the spiral manner, that is what is called as centrifugation. Now, these centrifugal forces will allow the small particles, which is particulate matter, to get settled down on the walls of the chamber. And fabric filters. Third one is the fabric filters. Now, these fabric filters, as I said, it is made up of a cotton, wool, or artificial fibers, or maybe ceramics, and these will act as a filter. So the flue gases is before releasing into the atmosphere to remove the particulate matter, flue gases is passed through a small such bags which consist of cotton or maybe artificial fibers or maybe ceramics. So these particles will be stick to the small threadings of these fabrics, and the pure gas which is free from these particulate matters will release into the atmosphere. And the fourth one is wet scrubbers. Now, in order to understand the wet scrubbers are the scrubbers which will be used for two varieties, especially of the particulate matter. One is solid dispersed in liquid, and the second one is liquid dispersed in solid. Now, gases enters into a converging section of the wet scrubber. So there are two sections. One is the converging section, and the second one is diverging section. When it enters into converging section, the gases and the water is sprayed from the top. So perpendicular to the movement of the gas, water is being sprayed, and when water is sprayed from the top and at the right angles to the movement of the gas, the small particles which is suspended in the gas will settle down at the bottom. Droplets of water will take away these particulate matter, and it will settle down at the bottom, and the gases which is free from particulate matter is released into the atmosphere. Now, electrostatic or Cottrell separators. Now, electrostatic separators is the static chambers which consist of two electrodes which are being charged, and it is being kept on the passage of the gas. Now the flue gas, like in the chimneys, on the both the side of the chimneys, these two electrodes are being kept, which will be charged. Flue gas is allowed to pass through these charged plates, which will be charged at an voltage of almost 40,000 volts. Very high electric charge will be placed on both the side of the emission of gas takes place. Especially this will be installed in industries. And when these gases will pass through these chimneys, which consist of Cottrell or an electrostatic separators, now you know that these gases are made up of ionized molecules. The gas gets completely ionized, and both cations and anions will form, and the cations will migrate towards cathode, anions will migrate towards anode. Now, the basic principle of electrostatic precipitator is to ionize the gas to convert into an cation and anion, and they migrate to the respective electrodes. And once they migrate to the respective electrodes, this will be collected at the electrodes and is being continuously removed. And the particles also gets charged, and it will be migrating to the respective electrodes, move towards respective electrodes, and get deposited on the walls of the electrodes. So in the electrostatic precipitators, the gas is made to ionize, and ions are collected along with the particulate matter on the walls of the electrodes and is being separated. So that is the principle of electrostatic precipitators. So electrostatic or a Cottrell separator or a precipitator, that is the role of an electrostatic precipitator. So five different ways of separating particulate matter. First is the gravitational settling chambers. They are the simple chambers, long hollow shaped chambers where the gravitational force is allowed to enter into the gas, and the matter which is present, which will be allowed to settle with the help of a gravitational force. Centrifugal separator, where there is a centrifugating apparatus will be placed and the gas is allowed to circulate, and the particulate matter which will be deposited on the walls of the centrifugating apparatus. Fabric filter, which consists of fibers. Wet scrubbers. Wet scrubbers is perpendicular to the movement of the gas. Water is being sprayed, and the small droplets of water will take away small particulate matter which is present in the gas, and it will be settled at the bottom of the chamber. Now, electrostatic precipitators, the electrodes are being placed and it will be charged at a voltage of almost 40,000 volts. And the flue gases which is made to enter into such a tunnel of electrostatic precipitators, so it will ionize the gas, and along with the ions of the gas, particulate matter will deposit on the electrodes, and it will be removed from the electrodes. So these are the ways to prevent the uh, particulate matter into the atmosphere. Thank you.